Whoa. So for this warm-up problem, we're talking about the moon orbiting around the Earth in a circular path due to the force of gravity between the two objects. That seem reasonable? Okay, so you got an object going around another object. Because of the force of gravity, the gravitational force is 2 times 10 to the 20th newtons. Distance between them is 3 times 10, or 3.8 times 10 to the 8th meters. The moon orbits with a velocity of 1,023 meters per second. What's the moon's mass? Are these some big numbers here, friends? Indeed. Can you still solve the problem, though? Yes, you can. All right, let's take a look. Let's start with givens. Does that sound okay? Givens seem like an easy place to start. So what you got? Tell me a given. You know the distance. The distance between the moon and the Earth, what does that represent in terms of circular motion, though? The radius. So I'm going to write it down as the radius. The radius is 3.8 times 10 to the 8th meters. Awesome. That's one thing. What else do we know? I got them both here. So we'll go Haley and then we'll go to Kaylee. Go ahead. The velocity. And that really is the tangential velocity, right? It's how fast it's going around so that if somebody snapped their fingers and gravity was gone, then the moon would travel off in what direction? If it was going around this way, right here, they snap their fingers, where's it going to go? Straight line, right? Straight line tangential velocity. It looks like this. It would go straight out like this. Yeah, in that direction, pretty darn fast, friends, at 1,023 meters per second. You don't realize how fast it's going, but everything's really big, so it's got to make a long path in those 30 days. All right. Any other givens that we know? Kaylee, you have one. The force is 2 times 10 to the 20th newtons. It's a big number. I don't want you to be scared, though, by the scientific notation. It's just so we don't have to write 20 zeros. That'd be a lot of zeros to write. Okay? All right. Any other givens that we know? The exponent is 20. Yes. What's our unknown? What is it? What is it that we're looking for? The mass of the moon. Okay. Probably. But relative to the Earth, not so much. Oh my gosh, what? All right. If I'm going to draw a free body diagram, the object that I'm drawing the free body diagram of is the thing that's going in a circle. So what is that in this case? The moon. If the moon is going in a circle, there's got to be at least one force acting. What is applying a force to the moon, you guys? The Earth, right? Now, this was a little bit weird. Does it matter where I draw that force? It really doesn't, because it depends on where in its rotation it is. Just for simplicity's sake, and only for simplicity's sake, I'm going to draw the force this way, the force of the Earth on the moon. But I could draw it in any direction. I want to make that very clear. What kind of force is this? It's a gravitational force, right? Force of the Earth on anything else, it's going to be gravitational force. So really, this thing here is an FG in our givens. I'm going to write that down so I know. It's the only force acting. It doesn't really matter whether I have it in the F net or F net X or F net Y, because there's only one force acting. So I'm just going to go ahead and write it up here at the top because I can. If there's only one force acting, is the moon accelerating? Is it speeding up? Slowing down? What's it doing that's making it accelerate? It is changing direction. Changing direction means that it's experiencing what kind of an acceleration? What's it called, you guys? You need to know this. It is a centripetal acceleration, right? Top right-hand corner of your equation sheet gives you a definition of centripetal acceleration. Anybody remember, or can you look and see what it is real quick? How do you calculate the centripetal acceleration, you guys? Say aloud, what'd you say? V squared over R, Jordan says, yeah. VT squared over R is equal to FG. Okay? If you did not get here before by yourself, now we're here. I'm going to give you just 1 minute to take this. You're solving for M. Plug in your values and figure it out. Okay? I'm going to give you just 1 minute. I want you to figure it out. All right. Did you get an answer? Solve this for M. So you got to get M all by itself, right? So M is equal to, it looks like it's going to be FG. I'll get it. My stylus is being goofy too. FG times R over VT squared. When you do the algebra, FG times R over VT squared, what'd you get? Because I divided by it to get it all by itself. Did you get an answer? Do you need me to go through that? Yeah, I can. So I want to get M all by itself. How do I get rid of the R? Multiply by R on both sides, right? So now I've got, oh, hello. I don't know. Something's going funky there. Okay, so R times FG. And then I need to get rid of the VT squared. Right now I'm multiplying by VT squared. How do I undo multiplying, friends? And that gives me this, right? Is it a big number or a small number? It's big. Makes sense, right? We're talking about the mass of the moon. It's a large rock. Yes? How big did you get? The value? 2 times 10 to the 20th? Yep. What'd you get? It's big. It should be big. Yeah. It's big. Yeah. But the mass of the Earth is like 10 to the 26th, I think, right? So, you know, I mean, it's pretty small relative. It's all dependent. All relative. All right. Physicists, I need you to listen up here, please. Today we've got a lot of things to do, and so I need to kind of walk you through what's going on so that you know what is coming. Oops, hold on. It is not the answers, unfortunately. I'd rewrite a test. Yeah, but you don't have the answers because we just changed the problem. So, you know, there you go. All right. Listen carefully. When you go to your assessment seats, you will need a calculator. You will need an equation sheet. We'll give that one to you. You'll need a pencil, and you'll also need your circular motion lab data. Okay? Assessment number 1 is the Unit 5 assessment. It looks very similar, would you agree, to the quiz that you took on Thursday. 2 questions, one on the front, one on the back. Friends, I need you to listen. So please put your eyes up here. Close your mouths. Assessment number 2 is working with the circular motion lab data. Okay? I'm going to assess all 3 of the last lab standards. So you'll turn in your lab data. You'll do the data processing and graph, and you'll do the conclusion evaluation. Okay? And then assessment number 3, there's a third one that I would like you to work on today. So you guys know that Mr. B is a student teacher, which means not only is he here to teach you, but he is also here to learn. And part of that process is that he needs to get some baseline data for you on your Unit 6 knowledge prior to him teaching Unit 6 to you, so that he can show the growth that you had while he's interacting with you. Does that make sense? So he's got a very short little survey. This is not graded. He's just looking at it. So he wants to see where you're at relative to where you will be at the end of the unit. Okay? So those are all 3 things need to be done. Question? don't think he would appreciate it. Oh, is that what you want? No. I don't think he would really appreciate it. Okay. Yeah, do your best. They're interesting questions. One last thing. There is a typo on both questions. Once you, or both tests, the first question. Once you get your quizzes, I will make an announcement of what those changes are because otherwise it's not going to make any sense. Okay? Guys, please be quiet. If you are planning to take this set of assessments as written, go ahead and go to your assessment seats. If you are not, come see me and we'll find a spot for you so that you've got a spot to work.
You should try.
Maybe. I don't know.